Hello students, welcome back to the discussion of the chapter Electrochemistry, and we are going to continue with our discussion of the sums based on Faraday's laws. So let us take one such numerical here. The question says that in certain electrolysis experiment, 0.561 grams of zinc is deposited in one cell containing zinc sulfate solution. Calculate the mass of copper deposited in another cell containing copper sulfate solution in series with zinc sulfate cell. Molar masses of zinc and copper are 65.4 and 63.5 grams per mole respectively. Students, here again zinc sulfate and copper sulfate cells are connected in series, isn't it? And that's the reason this numerical is based on Faraday's second law of electrolysis. Alright? So let us quickly write the data which has been given to us. Mass of zinc deposited is 0.561 grams. Molar mass of zinc is given as 65.4 grams per mole. Molar mass of copper is given as 63.5 grams per mole. What we are supposed to find here is the mass of copper deposited. And to find the mass, we know the formula from the number of moles, right? So number of moles is nothing but mass of substance deposited upon molar mass of the substance deposited. So here we know the molar mass of copper. So if we find the number of moles of copper, we will be able to find the mass of copper deposited, isn't it? So here this is the formula we should be using. But for finding the number of moles of copper, we need to use the formula for Faraday's second law of electrolysis, right? So here in solution, first we need to find the moles of zinc deposited, okay? So number of moles of zinc is nothing but mass of substance deposited upon molar mass of the substance. That is, here it is zinc, right? So mass of zinc here is 0.561. Its molar mass is 65.4. So the answer for moles of zinc deposited comes out to be 8.578 into 10 raised to minus 3. These are the moles of zinc, right? Now, the reaction which are taking place during electrolysis in zinc sulfate cell, we have Zn2 plus 2 electrons giving you Zn, right? So this is the half reaction for reduction of Zn2 plus. In copper sulfate cell, we have reduction of copper ions taking place. So Cu2 plus 2 electrons giving you Cu. So in both the cases, if you need to find the mole ratio, can I say for zinc, mole ratio is nothing but moles of zinc produced upon number of moles of electrons required, right? So here moles of zinc produced is 1, for which we need 2 moles of electrons. In short, the mole ratio for zinc comes out to be half. Similarly, if I want to find the mole ratio of copper, again, it is moles of copper produced upon number of moles of electrons required for 1 mole of copper, right? So basically here you have 1 by 2, which is again 0.5. So in short, the mole ratios for zinc as well as copper is coming out to be 0.5 each, isn't it? So here we have found the moles of zinc produced, and we have found the mole ratios for zinc as well as copper, right? Now, according to the second law of electrolysis, Faraday's second law of electrolysis, we have the formula here that moles of copper produced upon moles of zinc produced, which is equal to mole ratio of copper upon mole ratio of zinc, right? Therefore, moles of copper produced will be equal to mole ratio of copper upon mole ratio of zinc multiplied by moles of zinc produced, isn't it? But we know that the mole ratio of copper and zinc both are 0.5, isn't it? So 0.5 upon 0.5 multiplied by moles of zinc produced, that is 8.578 into 10 raised to minus 3. So precisely, I can say that moles of zinc produced actually is equal to moles of copper produced, right? That is 8.578 into 10 raised to minus 3. So many moles of copper are produced, and through this we will be able to find the mass of copper produced. Mass of copper produced, that is number of moles of copper multiplied by molar mass of copper. So here number of moles of copper, we know it is 8.578 into 10 raised to minus 3. Its molar mass is nothing but 63.5. So the answer comes out to be 0.5447 grams of copper. So that is the final answer for the mass of copper produced. I hope students you have got the clear idea with respect to this numerical. Thank you.